All right, 4.2 homework. So here we have exponential change of things in the bloodstream. And here we're going to use 5.2%. So per hour. So every hour your body filters out 5.2% of the amount of the drug that was in your system. And different drugs have different percentages for things like this, like caffeine is processed kind of like this in the body. Ibuprofen is kind of processed like this. There's lots of medications, drugs that do that. So let's see what we got. Let's put it together. Screenshot. Okay, so again, we have an exponential rate going on for the drug elimination. And the first question says, select the correct statement. The same amount of the drug will be eliminated in the first hour as the second. Well, that would be linear change. That describes linear change. Less of the drug will be eliminated in the first hour than the second hour. Okay, so we're eliminating from the bloodstream here. And if you think about the car depreciation problem, it lost more value in the beginning because it was worth more in the beginning. Okay, so I'm not sure about that. That seems like unlikely. More of the drug will be eliminated in the first hour and the second hour. And again, because of the percent, yeah, that's what's going to happen. Because at first we're eliminating 5.2% of 500, but then we're going to have less than 500. And when we take 5.2% of that new number, that smaller number, we're going to get a smaller result. So it turns out it's this last one in my version. Yours might be in a different order. More of the drug is eliminated in the first hour than the second hour. So let's double check that. So we're given a rate. It's being eliminated, so that means it's a negative 5.2%. We're giving a starting amount, I call that P, 500 milligrams. And again, we have per hour here. Time should also be measured in hours. So we have T hours. And they want me to use D for the drug and T for time. So D equals the starting amount, 500, times 1 plus your rate as a decimal. So that would be negative 5.2 over 100, which is negative 0.052. So I'm going to subtract 0.052. Double check that on a calculator. And this cleanup here is usually pretty easy on a calculator, so I think it's worth doing. 1 minus 0.052 gives me 0.948. So that's what's left behind each hour. So now I have 500 times 0.948 to the power T. So that's my drug elimination. And then they want to know, so that's my formula for right here. Then they want to know what happens 6 hours later, and we would just plug in 6 to that. And I just want to show you a couple of things. So we could look at this on a spreadsheet. We could look at this on a calculator. Since I already have my spreadsheet out, I'm going to take a look at it that way. So I'm going to look at my hours here, my T, and how much of the drug I have. And so we start off always with 0 and the initial amount. And then I just enter my formula, and I can do maybe 1, 2, 3, 4, 5, 6 hours later. And we're going to reinvestigate that other question, the first question, like is more eliminated in the beginning or at the end? And our formula is just equals that starting amount, 500, times, we calculated the base, the multiplier was 0.948, power, shift 6 to get that little hat key button thing, and then we just click on the number of hours next to us there. Enter, sure, we can fill it down or manually fill it down by clicking back on it, grabbing the bottom right corner. All right, so I've calculated here what's happening 6 hours later. But what I want to see is a graph of this to check out that first question again. And we might need to graph more than 6 hours to see this, but let's check it out. Let's see what we see. So once I make that calculation, spreadsheet repeats the calculation super easy for me. I just grab a chart. Okay, so it's kind of hard to see whether there's more at first than later. So I think I need to graph some more. So let's delete this and try again. Let's go for like, I don't know, 24 hours later. So to do that, I can just fill these bottom two down. Okay, 30 hours later. Let's see what that looks like. So I need to reselect all of them, graph it. Okay, so if you line up a piece of paper to this, what you should see is it's steeper in the beginning here than it is down here at the bottom. So that means we've lost more in the beginning than we did later. If you're still not sure about that, by looking, you could just calculate the loss. So if we look at just the amount lost, that would be just a subtraction. What's 500 minus 474? What's 449 minus 474, and so on. So in the second cell, I just say take the previous number minus the current number, and then sure, we'll fill it down. So I can see at the beginning, we lost in the first hour 26 milligrams, but then it jumps down to 24, 23, 22, 20. So the amount we're losing is decreasing because it's always 5%, 5.2% loss of the current number. Okay, so back here, more of the drug will be eliminated in the first hour than the second, and that's always true in a percent decrease problem. Always, 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 because we start with the biggest number and we lose from there. And when you take a percent of a smaller number, you get a smaller amount of loss. All right, so again, spreadsheet, super helpful. We've got a formula. We calculated the amount for 6 hours later, and we got this done.